Sickle cell disease is an inherited disorder, and it can cause pain in the individual. So normal red blood cells are round, and sickle cells have a crescent shape. So it's more difficult for them to pass through the blood vessels and arteries. And so they become sticky and cause pain in the individual. So it can also block the blood flow, causing a sickle cell crisis. So say there are two parents that have they're heterozygous, so they have the sickle cell gene and a non-sickle cell gene. There's a 25% chance that their child will have sickle cell disease because they'll both, that child will inherit both of the sickle cell genes and be homozygous for sickle cell disease. And then there's a 50% chance that the child would be a carrier. So they would have one gene that is sickle cell from a parent, one gene that is not sickle cell from a parent. And so 50% chance that they would be heterozygous. And then a 25% chance that they would be homozygous and not carry the sickle cell gene. So there is some evidence based in Kenya, which was really interesting to me because I've traveled to Kenya and worked with people there and still have a lot of friends that work in Kenya. And so I forwarded the video onto them so that they could learn about this as well. But in a non-malaria environment, the absence of malaria, there's a strong selection against the sickle cell gene. So there would be a 75% chance that someone would not end up with sickle cell and a 25% chance that they would. But in a malarial environment, if the individuals are born with 2 copies of the sickle cell gene and those born with 2 copies of the normal gene are both at a disadvantage, because someone with the malarial gene would have resistance to malaria. So it's kind of bad to get, well, obviously it's bad to get malaria, it's bad to get sickle cell disease. So in a malarial environment though, those with sickle cell have some resistance to malaria, which is super interesting. So one would get sickle cell disease, the other would be vulnerable to malaria. So I think it's really informative that this connection was made. Hopefully that genetically they'll be able to find a cure for both malaria and sickle cell disease. I've had a patient that has had sickle cell disease before, and just in a brief conversation with him and talking about what his life is like with the pain and things, I think it's something definitely to denote that we don't always see the results of sickle cell or sickle cell anemia because we don't always know people with it. But also the sickle cell dies sooner than a normal red blood cell, so there's less red blood cells in the body that can carry oxygen. So therefore, people with sickle cell become anemic because there's a lack of red blood cells in their body. So that is sickle cell anemia.